Good morning, everybody. Lecture 18 was the founding day lecture. So today's lecture is 19. YouTube, you do not have to watch lecture 18 because there is no lecture 18. This is lecture 19. Tonight we will have lecture 19.5, which is an additional lecture because we're late in the material a little bit, not much. Attendance will not be taken, but it will be appreciated. And I will leave you thinking what do I mean by appreciate, okay? Today, we will continue solving examples in the using complex impedances. All got the calculators ready? Put them in the complex mode and degrees, okay? The numbers, get the markers. Okay, so recall the most important table is that table, right? You remember that table? Yes. So today we'll keep using it for another example. That is this example, 5.6. The title of it is Series and Parallel Combinations or Combinations of Complex Impedances. Now we don't have a series RLC, resistor, inductor, capacitor, but we have a capacitor that is in parallel with a resistor, all in series with an inductor. So let's try to solve the example. Now here is an important point. What's the voltage source phasor? It's sine, so we need to convert it to cosine. So it has to be what? 10 angle. The sine is at angle 0. So convert it, Muayyad.
Cosine.
What is the phasor?
0.
10 angle?
0.
That is wrong. This is sine.
Yes, it's cosine 1000 t.
No.
Minus 90.
Minus 90. So this will be 10 angle.
Minus 90.
Get it? That's a voltage source. We're professionals, right? So we put the inductor. Okay, what is omega? Always write omega in the corner. What is omega? Is whatever before the t. Okay? Omega is 1000. What's the unit? Radians per second. Sometimes omega comes at like 2 pi 20 maybe. Sometimes they write it that way, but in some examples to make the numbers easy, it's written as a number. Get it? Don't get confused. Now let's convert the impedance. It's 0.1, convert it. All use the calculator. It's going to be 0.1 times 1000 times J. It's 100 J ohms, right? The resistor, we keep it as it is, right? How about the capacitor? 1 over J omega C. It's 1 over J times 1000 times 10 micro. 10 E minus 6. Okay? It's what? Minus J 100. What's the unit? Ohm. We're professionals, right? Do we see any currents leaving? Read the question. Find the voltage VC. Find the phasor currents. So we have to define some currents, right? So let's continue. We're professionals, right? Plus minus, plus minus, plus minus. So let's call this current is I source. Let's call this current IR. Let's call this current IC. Do we agree with this notation? You can call it IS, I1, I2. It doesn't matter, okay? Now how to solve this example? I want to calculate VC, which is VR. So clearly if I find the impedance here, I can use VDR, right? So it's going to be, VC is going to be what? This impedance over this impedance plus this equivalent impedance. So you need to have a plan, and that's our plan. You can't just start by calculating current. If you don't want the lecture, you can leave. Okay? I gave you the exemptions to leave. And I will put mark you as attendant if you don't want to attend. Get it? Please. So VC is what? VDR. So it's going to be Z RC. The book calls it RC, which is the parallel combination between resistor and capacitor, over Z RC plus ZL times VS. What is VS? Okay, what's the number? 10 angle minus 90. Get it? Okay, what is ZRC? ZRC is nothing but 1 over R, which is what? 100 plus 1 over minus J100. Inverse. Don't forget the inverse. You treat them as like you're treating resistors. Abdullah al-Qahtani. Same argument, okay? Can you please tell me what is the final answer of that? Did you bring your calculator? Did you buy a calculator? Congratulations. Where is your calculator? Yeah, you didn't bring it? Okay, you have to sit with a colleague and try to calculate the numbers, or use iPad calculator. لمصلحتك يا شباب. When the test comes and you don't have enough practice, you will waste lots of time. So what is the final answer?
50 minus 50.
Well, let's use it as phasors. So it's 50 minus 50J, which is equivalent of
50.
shift to 3,
70.7 angle
70.71 angle minus 45 degrees. What's the unit? Ohm. So now I can calculate VC directly, because I know Z sub L, I know Z sub RC. Yes.
كان نسوي CDR مثلا
You can find all ZRC series with that, then you calculate the current. But read the question. The question asks you to find voltage V sub C first. That's why I wrote this formula. Later he will ask us to calculate the current, but you will find it easier to do it following read the question. Remember, in EE, reading the question is third of the problem, not half. The last third is doing the right calculators. So let's do it. So VC equals VS times 70.71 angle minus 45 over 70.71 angle minus 45 plus J. What is Z sub L? What is Z sub L? 100J, right? And we know VS muayyad. Can you remind me? It's 10 angle
minus 1.
So this number times this number over this number plus that number, do it. And don't complain about the test, you don't have enough time. Please. YouTube, you have to do it real time. 70.71 angle minus 45 divide by 70.71 angle minus 45 plus 100. We forgot the J. We forgot the J. There's a J here. And I always write it as a phasor notation. I think it's what? 10 angle 180?
No, 6.8.
I made a mistake. 10 angle minus 90 times 70.7 angle minus 45 over 70.7 angle minus 45.
Yes.
Minus 10. Yes. 10 angle 180.
That's what I got. 10 angle 180 degrees. Something is wrong. I don't know. Yeah, that's VC. 10 angle minus 180. Get it? What's the unit? Volts. Then the question asks, find the voltage VC in a steady state. I told you, don't get scared from the word steady state. What does it mean? L'ahmar. What is l'ahmar? What does it mean steady state? Steady state is after enough time. No, it doesn't mean doesn't change with time. Steady state يعني حالة الاستقرار في السيستم. You don't look at the transients, الripples والأشياء هذه. Get it? So, he's asking, find the phasor current. Why he said phasor current? إيش معنى phasor current يا شباب؟ معناته your answer should be as a phasor. Get it? So let's find it. So let's start with I sub L. What is I sub L? Well, to calculate I sub L, you have to use, it's very simple, it is Vs over Z equivalent. Because if you calculate the parallel combination, add it in series with that, divide Vs over the whole Z equivalent, you get IL, which is, we call it Is. So you can call it that way. You can call it Is equals IL equals Vs over Z equivalent. And now, what is Vs? 100 minus 90. What is Z equivalent? Is ZL plus ZRC, right? So it's 10 minus 90 over J100. It's that number, right? Plus 70.71 angle minus 45. What's the final answer? 10 angle minus 90 over J times 100. All do the calculations. What did you calculate? I see, Muhammad. You're wasting an opportunity, a learning opportunity during the class. Let me know if it's 0.14 angle minus 135 amps. It's the same?
Yes.
That is I. Here they call it I call it IS, you can call it IL, it doesn't matter. Now, what is I sub R? I sub R is actually VR over R. But VR in parallel with VC. So it is VC. Get it? VR is what, يا what? It's VC. Did you get that number? Same? Try to get it. What is VR is VC. What is VC? 10 angle 80. Is it minus 80 or minus 80? That 10 angle minus. Well, 180 is equivalent of minus 80. 180 degrees is like minus 180 degrees. It's the same thing. Over 100, which is going to be what? 1 angle 180. Minus 180 amps. And what is IC? KCL is IS minus IR, which is what? 0.14 angle minus 135 minus 1 angle.
0.1. Should be 0.1.
Which one 0.1? The IC?
The IR.
Oh, you're right. 0.1, 0.1. So I see it should be 0.099 angle minus 90 degrees amp. 0.1 angle minus 90, 0.1 angle minus 80, 0.1414 angle minus 35 amps, and the voltage. Now plotting them, you will notice that IR is at angle minus 80, IC is at angle minus 90, I is at an angle of minus 135. Minus 135 is you start from here 90 degree, and then what? 45 degree. 90 plus 45 is minus 135. And you can see the V source is at minus 90. Now you can sketch that very easily. We're not going to solve it. Any question about 5.6?
And الكرنت اللي يكون parallel مع البي لها معنى ولا ما لها؟
What do you mean by current parallel?
اللي في الجراف اللي قبل شوي.
Well, what we can see is IC is in phase with VS. But do not focus much on it, okay? Focus on getting the right numbers. And know how to sketch generic. The meaning is, again, you compare two comparable values like VC and IC. So VC is not plotted here, but the right way is to say IC is at angle what? Minus 90, but what is VC? VC is at angle minus 180. So VC is here, IC is here. This means what? Means current is leading the voltage. IC is leading VC. IC is leading VC. Now, this is not the whole thing plotted. This is just the currents and VS plotted. The three currents and VS plotted. But the right way, if you want to compare leading and lagging, it has to be VC and IC, or VL and IL, or VR and IR. Now, I can ask you a question. Is VR and IR always in phase? True or false?
Yeah.
The resistor is always in phase. Okay? Node voltage analysis for complex numbers. This one is a bit challenging because the calculator cannot solve a system of complex variables. Okay? We're gonna use Kramer's rule, قاعدة Kramer, because the calculator cannot solve complex numbers in the system. So what do we have? Use node voltage technique to find V1. What is V1? This one. And of course V2. Now, Muayyad, your favorite problem. Fix that to me. What's this current source?
2 cosine of 100.
No, give me as a phasor. 2 angle 1.
Minus 90.
2 angle minus 90.
So we forget
Don't
about-
forget, that's a trick. It will come in the test. The sign has to be cosine. Who asked the question?
No, we forget about the sinusoidal. خلاص على طول phase.
Yeah, it's better to put them as phasor. The ground, keep the resistor, right? Okay, what's the omega? What's the omega? Not that omega is same, 100, 100. You cannot have two voltage sources with two different omegas. The system will oscillate. Doesn't make sense. Get it? So the two current sources have the same omega. You can even combine them to be 2 plus 1.5. It will be 3.5. Well, they're not in phase. They can't combine them. Remember, the sources can be different in phases, but they should have the same frequency. What is omega? 100. So what is C? We're professionals. 1 over J. 1 over J times 100 times 2000 micro. It's minus 5J, right? What's the unit? Anybody who doesn't know how we got the minus 5J? It's 1 over J times 200 times 100 times 2000 micro. Micro is 10 to minus 6, which we do it, use the button, this button in the calculator, and then you type minus 6 after. If you don't know, talk to me, okay? What is your calculator? Okay. Khadi, what is your calculator? Oh, Khadi. I always confuse between you. Walid? Khadi. I always confuse between you. معلش. لأن أحيانا واحد يجلس قدام وواحد يجلس ورا. وفي شبه شوي مو كثير. Okay? Point 1. Compare that يا شباب. Point 1 times 100 times J. 10J. Ohm. مؤيد. What's the voltage source phasor?
1.3.
No, 1.5. angle?
minus 9.
No.
0.
هو حافظ بس نقص 90.
Don't memorize. Okay, let's do V1, V2 node voltage, KCL. Let's do it. It's going to be what? Minus 2 angle 90, which is this current source leaving, minus 2, plus V1 over 10, plus V1 minus V2 over what? Minus J5 equals 0. That's equation 1. What is equation 2? V2 minus V1 over minus J5 plus V2 over 10J, the inductance impedance, minus 1.5 angle 0. Converted to the system. Let's do it in a system. We're professionals. V1, V2. What's the coefficient of V1? It's 1 over 10 plus 1 over minus J5, right? You agree with me? In the exam, try to simplify things. Do not try to calculate everything later. Okay? What are the coefficients of V2? Minus over minus J5 is what? 1 over J5. And then minus 2 angle 90, we bring them to the right hand side. It will be what?
2 angle 90.
2 angle 90 degrees. How about this one? V1 is what? 1 over J5. V2?
بالماينس ال V1 ده.
Well, it's a minus over minus. So it will be 1 over J5. Remember always to try to simplify things as much as possible. V2 has what? 1 over 10J plus 1 over minus J5. You can keep the negative at the bottom, right? Equals 1.5 angle. So that's a system. And let me see if we have a similar system. Now, how to solve such systems of equation? Well, to do it, we have to use Kramer's method. Kramer's method tells you have to name the components of your system as A, B, C, D, E, F. Then, V1 is actually E times D minus B times F over AD minus BC. باختصار هي المحددات, the determinant of the matrices. To calculate V1, you have to find the determinant of ED minus BF. Basically, you put EF instead of A and C, and you take the determinant, المحددة, which is ED minus BF, over the original determinant, which is AD minus CB, or BC. CB is BC, the same. So it's the determinant of, I think they call it the co-matrix. اللي هي you replace A and C with E and F and you take the determinant. And you take the determinant of, so what is A? A, B, C, D, E, F. So what is V1? V1 is what? You put EF here, so it's going to be what? ED minus BF over AD minus BC. So what is ED? ED is what? 2 angle 90 times 1 over 10 minus or plus 1 over minus j5 minus bf. What is bf? 1 over b is 1 over j5 times f, which is 1.5 angle 0, over AD 1 over 10 plus 1 over minus j5 times 1 over 10j plus 1 over minus j5 minus BD or BC, which is 1 over j5 times 1 over j5. Any mistake? Now, do you want to calculate it all at once, or you want to calculate it term by term? Let's try, maybe it works. 2 angle 90 times 1 over 10 plus 1 over minus j times 5. Minus 1 over j times 5 times 1.5, angle 0 is just 1.5, divided by 1 over 10 plus 1 over minus 5 times j times, let me calculate the numerator alone and denominator alone. It's hard. The numerator is going to be what? Minus 0.4 plus 0.5j. The numerator. Did you get that number? Did you get that number? I want just one confirmation.
For the
Just the numerator. البسط الحالة. لا تحسب بسط ومقام بتلخبط. احسب البسط لحاله.
minus 0.4 plus 0.5 j.
J, not K, J. So that's the right number. Let's do the numerator. Denominator, المقام. 1 over 10 plus 1 over minus j times 5 times 1 over 10 j plus 1 over minus j times 5 minus 1 over j5, I'm going to put square, which is the same. So that is what? 0.02 plus 0.01j. So the final answer will be minus 6 plus 28j, which is 28.6 angle 102 volts. Let me verify. I don't know.
طلع نفس الشيء.
It's wrong.
الباص غير عندي.
What?
اللي تحت غير طلع عندي.
Okay, let's verify it. 1 over 10 plus. I think I have a mistake here. So that's what? AD minus BC. Now I got the same denominator.
نجرب term by term.
Yeah, I don't know what's going on. By the way, this could be wrong. That's why we want to do the exercise together. Well, let me verify that the coefficients are true. Guys, if you notice,
Doctor, what is the answer?
that's the answer. 16.1 angle 29. So 2 angle 90 times D Try to use the system here. Nice, I'm still getting the
في AD
AD. Okay, what's wrong with AD?
1 over 10J المفروض ولا
No, it's 1 over 10
why?
plus 1 over.
Because we will bring EF into the first matrix.
Well, it is 1 over 10 from the resistor plus 1 over minus 5J. Well, I checked the coefficients. Those coefficients are the same. So the only explanation is most likely the book is wrong. That's my theory. Come. Anybody?
احنا دكتور ممكن نضرب هذه في الدي
ED.
10 جي.
You're right. Thank you. Fix it. See how one mistake can waste the whole class.
استوى البونص.
Yeah, I'll give you bonus. 0.1. Adewat. Remind me. Who got the bonus so far? You, and him. You got the bonus, Mr. No. You got do you get a bonus?
Yes.
And you got a bonus?
أنا
No,
مش
you didn't get a bonus.
مش على كم نص وأنا واحد.
انت half. Who got the half?
أنا كلهم عارف.
No, واحد got a half.
أنا
انت
واحد.
أخذت السراج.
لا.
أنا واحد أتوقع.
Talk to me after the, I don't know, not now. Talk to me later. But Alewat, you got the bonus, okay? Minus 0.2 plus J 0.3. It's better to be the right answer. Yes. No, not really. The angle is different. Come on, the angle is not correct. We're not getting the right angle.
You're at 90 but it's minus 90.
Hmm?
It's minus 90. 2 minus 90.
Why? It's your fault. 2 minus 90.
Get twice 90.
Okay, 2 minus 90. You see how this math is hard? Imagine doing this in major 2.
دكتور بس الماينس اللي تحت تغير المفروض.
Yeah, but I better do. 2 angle minus 90 plus 1 over 10j plus 1 over minus 5j minus 1.5 over j times 5. So that number will be what? Always verify that you're typing the right numbers, okay? That will be 0 plus 0.2. So 0.2 plus 0.3j divided by 0.02 plus 0.01j. That will be 16.1 angle 29 degrees. The unit is volts. We finally match the answer. Get it? Get it? Couple of mistakes I have done. I forgot the minus 90. I forgot the 1 over 10j. But everything else works. Note that the question only asks about V1, so no need to calculate V2. And then to bring it back to the cosine expression, it will be 16.1 times cosine 100t plus the phase shift 29.7. And to make it sine, it has to be what? Sine of whatever? 29 minus 90 is going to be almost minus 60. Get it? If you want to convert it back to sine. I'm not going to solve this example, but this is to review how to solve a system of Kramer's rule. I'm not going to solve the same numbers. It's almost the same way. What time is it? We have 10 more minutes. My goal is to finish this example and that example, but I don't know if we'll be able to do it. Let's do the mesh analysis. Okay? Any questions so far? You see the math is getting harder. So you have to practice. Always practice. Do the homework. Mesh, your favorite. For the mesh, you also have to solve a system of equations, right? So you have to use Kramer's rule. But let's see. I don't know how it looks like. Here we have two loops, and the question asks, use the mesh method to solve for IA and IB. And IA and IB are always what? Phasors. You can convert from phasor to time domain. We're professionals. Start with the voltage source. Why? What's the phasor?
100 angle 0.
What's the omega?
100.
1000. Then we have an inductor. Convert it quickly. 0.1 times 1000.
100. 100.
100J ohms. A resistor of 100. Keep it, right? Capacitor. 1 over J times 5 micro times 1000. That will be what? Minus 200 J. And then we have another inductor of 0.1, which is the same. 100J. Ohms. Okay? Ohms. We are professionals, right? With the signs, that's IA and that's IB. So what's the current here? Plus minus, IA minus, IB, plus minus here what we have? IB, right? Get it?
Yes.
And then maybe we can add the ground here. Any question how to set up this? You have to set it up right. Right, Rian? This is IA. Here plus minus IA minus IB. Here we have IB. Get it? What's the problem, Justin? Any mistake? Any problem?
No.
Okay. Who wants to be the KVL? Justin. This is a Justin. Start. Voltage rise, voltage drop.
Voltage rise with the sign.
100 angle 0 plus 100 angle 0. And then
Voltage drop minus 100 J.
times IA.
Right.
مثلا
And then voltage rise, voltage drop.
drop
Minus 100 times
IA minus IB
equal
0.
half the. You can come. You're the second KVL here.
voltage rise.
You can come. If you can't see, you can come.
I can see. Voltage rise
Give me the, okay, voltage rise plus
plus 100
times,
IA minus IB.
yeah, remember you keep the current, so that you avoid passive sign
Okay.
configuration. We don't like it, especially here. We don't like it. Then
Voltage drop
minus,
minus what minus positive.
so plus 200J times,
IB.
and then voltage drop
100
minus 100J times
IB.
equal
0.
Abbad, standard form. Help me with the standard form, Al Abbad.
اللي بس نقطع يا دكتور ماشي.
You can come next to me.
minus 100J
Okay, you have to be careful. Minus 100J.
minus 100.
Okay, so can I say it minus 100 minus 100J?
Yeah.
Just flip.
Yeah.
Okay, because we prefer to write the real before the imaginary. How about IB?
100
Plus,
100
and then this one,
to right, so minus 100 angle 0.
minus 100 and, okay. Anas, the second row, let's do it.
100
So IA is what?
100
Okay, how about IB?
باقي IA 200J.
No, we only have only 100 IA. This is B, B, B.
ثانية B.
Okay, this is B, this is B, this is B.
Okay, خلاص 100
And then it will be 100 plus J100, right? Because 200 minus 100 is 100. Do we have a constant? 0.
minus 1.
No, we don't have a constant.
minus 100 plus 100.
Oh, you're right. Minus 100 plus 200J. We don't have a constant. So F is what? 0. That will make it easier. Kramer's rule. So you want to calculate IA. Let's go back to Kramer's rule. Write it on the side. So IA is what? ED minus BF over AB minus CD. What is IB? AF minus EC over AB minus CD. You can write this on. You can, I don't know if but we'll try to provide it to you if you want. We'll try, we'll see. So what is IA? What is ED? ED is what? A, B, C, D, E, F. So ED is what? Minus 100 angle 0 times
Minus 100 plus 100 J.
minus 100 plus J times 100 minus 0, BF is 0. And what's AB minus CD? Is minus 100 minus J100 times minus 100 plus J100 minus 100 times 100, which is 10,000. Okay, what's the numerator? Minus 100 times minus 100 plus J times 100 over, okay, that's 10,000 minus J, 10,000 over minus 100 times J times minus 100 plus 100 times J minus 10,000. That would be 10,000 So that will be what? 1 minus j. 1 minus j converted to a phasor will be 1.41 angle minus 45 degrees amps. I want to verify.
Yes.
This is 1.4 angle minus 45 because it's cosine. If you want to make it sine, it will be the same. Sine minus 45.
ماشي يقول لي ما في ايرور.
Math error because you put 1j without a multiplication. You have to put times j. No, because
Make the j after the number.
yeah, maybe you put the j before.
No, same.
Because there is different types, letter 9 or this.
Can I take 5 minutes extra? Do you have a class? I'm gonna, okay. I don't know why it's wrong. What do you mean? Which one you calculated? This one?
النيوميريتور.
Okay, just put minus 100, angle 0, times minus 100 plus j times 100.
You cannot multiply it.
Yeah, you can't multiply, so it's bad news. I don't know.
لازم احولها كلها الجي او كلها
We need to convert it.
Yeah, the only solution is to convert this into a phasor.
Yes.
Cheap calculator. My calculator is better. That's why you should get KCU FX. This is the best.
100 angle 0 هي اللي تعطيني
Yeah, you have to convert this into just minus 100. Remove the angle 0. And then it will work. That's a shortcut. Now what is IB, please? AF is what? Minus AC. Is 0 minus EC. What is EC? What is E, ya shabab? Minus 100, angle 0. I'm not going to put angle 0 times 100 over the determinant. We already calculated the determinant, which is what? 10,000. So it's going to be what?
What?
1 angle 0 amps. What is this, ya Muayyad? 1 angle 0. So I'm not going to have a checkpoint. Consider this as a checkpoint because the problem is hard enough to be a checkpoint, okay? The last example, we'll probably maybe start solving this maybe in the help session today. So what did we do today? 1 minute. We did solve node voltage. And we learned that you treat it as a regular node voltage, except you need to use Kramer's rule. After that, we did solve a mesh, and you have to use Kramer's rule. Try to solve this exercise maybe 6:30 p.m. Please attend, okay? I appreciate you attending. Thank you so much. If you have questions, let me know. And you can come and talk about the calculator. Any question?
Thank you.